Welcome to the Chemistry, Biology, and Math Revision Hub. Today we're going through the Pearson Edexcel International A-Level Chemistry Unit 1 for January 2025. Let's begin with the first question. Question 1. What is the total number of atoms in 8.8 grams of carbon dioxide? First, remember that the molecular mass of CO2 is 44. Avogadro constant equals 6.02 times 10 to the power of 23. So first, we need to find the number of moles of carbon dioxide. We use the formula moles equals mass divided by molar mass. So 8.8 divided by 44 gives us 0.2 moles of CO2 molecules. Now every CO2 molecule contains 3 atoms, 1 carbon and 2 oxygen atoms. So 0.2 multiplied by 3 gives 0.6 moles of atoms. Then we multiply by Avogadro's constant. We get approximately 3.6 times 10 to the power of 23. The final answer is therefore B. Question 2. How many moles of ions are there in 40 cubic centimeters of a solution of 0.05 moles of magnesium nitrate? First, magnesium nitrate dissociates into 3 ions, 1 magnesium ion and 2 nitrate ions. Now, using the formula, moles equals concentration times volume. We have 0.05 times 40 times 3 divided by 1000. Dividing by 1000 converts the volume to decimeters cubed. We get 0.006 mole. The answer is therefore C. Question 3. A water molecule containing the isotopes of hydrogen and oxygen hydrogen 1 and oxygen 16 has a mass of 2.9908 times 10 to the power of minus 23 grams. What is the mass of an atomic mass unit measured in grams? They have given us the corresponding relative atomic masses. Water has 2 hydrogen atoms and 1 oxygen atom, so 2 times 1.0080 plus 15.995 gives us 18.011. Now, the mass of the water molecule given is 2.9908 times 10 to the power of minus 23 grams. Set up a ratio. 18.011 atomic mass units corresponds to the given mass in grams, so 1 mole would be 2.9908 times 10 to the power of minus 23 divided by 18.011. This gives option C as the answer. Question 4. NXO4 is an oxide of nitrogen. The percentage by mass of oxygen in this oxide is 69.57%. What is the relative molecular mass of this oxide? To answer this, we know that oxygen's relative atomic mass is 16. The mass of oxygen atoms in this oxide of nitrogen is 4 times 16 equals 64. Using the formula for percentage by mass, 64 divided by relative molecular mass times 100 equals 69.57. Rearranging, the relative molecular mass is 64 times 100 divided by 69.57. Calculating, we get about 92. The answer is therefore B. Question 5. 4 different solutions contain chloride ions. 3 of the solutions contain the same number of moles of chloride ions. Which solution contains a different number? First, let's find the moles for each solution carefully. For A, 0.80 times 15 divided by 1000 equals 0.012 moles. For B, there are 3 chloride ions. So 3 times 0.40 times 10 divided by 1000 gives 0.012 moles. For C, there are 2 chloride ions, so 2 times 0.90 times 10 divided by 1000 equals 0.018 moles. For D, there is 1 chloride ion, so 0.60 times 20 divided by 1000 gives 0.012 moles. So A, B, and D all have the same number of chloride ions, 0.012 moles, but C is different with 0.018 moles. Final answer, option C. Question 6. A solution contains 95 parts per million of a solute. What mass of solute is dissolved in 1 kilogram of this solution? Since 1 kilogram equals 1000 grams, we set up 95 divided by 10 to the power of 6 times 1000, which gives 0.095 grams. Final answer, option C. Question 7. A sample of hydrated magnesium sulfate contains 43% by mass of water. What is the formula of this magnesium sulfate? First, the molar mass of magnesium sulfate is 120.4. Since we are given the number of water molecules for all answer options, we have to calculate and see which compound matches 43%. From my calculations, as you see here, only option B gave a value close to 43%, so B is the answer. Question 8. Ethanoic acid can be produced by the oxidation of butane. As shown here, the atom economy by mass for the production of ethanoic acid is: first, find the mass of the desired product, which is 240, then total mass of products, which is 276. Atom economy is mass of desired product divided by total mass times 100, so 240 divided by 276 times 100. This gives 86.96%, which rounds to about 87%. The answer is therefore D. Question 9. The first four ionization energies of gallium, indium, germanium, and tin are shown. Which values are the first four ionization energies of gallium? Here, gallium's electron configuration is argon, 4s2, 3d10, 4p1. First electron removed from 4p, then 2 from 4s, and then 1 from the 3d. First ionization is low, as it is easy to remove the 4p electron, then slightly higher to remove 4s electrons, then a much bigger jump, 3d is deeper and harder. So the answer is B. Question 10. Sulfur has a higher melting temperature than white phosphorus. Which is a possible reason? Sulfur contains more electrons, therefore lots of intermolecular London forces compared to phosphorus. Thus more energy is needed to melt sulfur. The answer is therefore D. Question 11. Which species are arranged in order of increasing radius? Let's reason this out. Potassium ion, chloride, and argon are all isoelectronic. Bromide ions have more electron shells, so the radius of bromide is the biggest. However, for the isoelectronic ones, the one with more protons has greater attraction to the outer shell, hence a smaller radius. So the order of increasing radius is potassium, argon, chloride, and finally bromide. The answer is therefore A. Question 12. Which cation would be the most polarizing? Polarization is determined by the charge and size of both ions bonded to each other. For a cation to be more polarizing, it should have a higher charge and a smaller size. This allows it to attract the electrons of the anion better, distorting the electron cloud. The answer is therefore A. Question 13. In the gas phase, phosphorus pentachloride exists as molecules. They are trigonal bipyramidal. The structure is shown here. Each chlorine atom can be replaced one at a time by a fluorine atom. The two axial chlorine atoms are replaced before the three equatorial atoms. Which of the resulting molecules does not have a permanent dipole? Remember, when you replace atoms, if the polar bonds cancel out, there's no net dipole. For A, the fluorine is different from the chlorines, so it's going to create a dipole. For B, two fluorines replacing two axial chlorines, they are positioned symmetrically opposite each other. So the dipoles cancel out, so not polar. Looking at my two other structures in blue for C and D, the dipoles will cancel out. Therefore, the answer is B. Question 14. Which hazard warning symbol would be found on a bottle of hexane? Remember, hexane is a hydrocarbon, which is very flammable. When you look at the hazard symbols, A represents flammable. So this is the answer. Question 15. What is the IUPAC name for the hydrocarbon shown? So the structure shows a 10-carbon chain, meaning it's based on decane. There are also two side chains, two methyl groups, attached at carbons 3 and 4. Putting it together, the structure is 3,4-dimethyldecaene. The answer is therefore B. Question 16. Which statement about the cracking of crude oil is true? Here we are given 4 statements. Please remember that cracking breaks big hydrocarbons into smaller ones. It doesn't purify the mixture or fully separate saturated and unsaturated compounds. It only reduces the average number of carbon atoms per molecule. That's why we get small alkanes and alkynes for fuel. Therefore, the correct answer is D. Question 17. Bromine and bromine water can be used to test for a carbon-carbon double bond. When bromine water reacts with this alkene, there is one major organic product. which is the skeletal formula of the major product. First, please remember that the major product is formed through the most stable carbocation pathway. In this reaction, the major carbocation is tertiary, so we form the alcohol where the bromine and OH add across the double bond, as I showed down here. Our answer is therefore option A. Question 18. Which of these formulae are correct for 1,4-diethylcyclohexane? Looking carefully, filling in the carbons and hydrogens in the skeletal formula, there are 10 carbons and 18 hydrogens. This corresponds with the molecular formula. Also, when we calculate the smallest whole number ratio, we get the same empirical formula. So all formulae are correct. The answer is therefore D. Question 19. Beta-farnesin is an alarm pheromone released by aphids. They have included the structure here. Then they ask, how many pi bonds and how many sigma bonds are there? Looking at the structure, 4 pi bonds, 1 for each double bond. Sigma bonds are all the single bonds, counted carefully, making 38. Therefore, the answer is B. Question 20. Which structure is a Z isomer? Here, Z isomer means higher priority groups are on the same side of the double bond. You can see from the parts in red that for the first 3 answer options, the higher priority groups are on opposite sides, making them E isomers. Only option D qualifies as a Z isomer. The answer is therefore D. Question 21. Chloroethene and 1-chloropropene are the first 2 members of a homologous series. 1-chloropropene exists as 2 geometric isomers. The first part says, draw the displayed formulae of chloroethene and 1 geometric isomer of 1-chloropropene. Here for chloroethene, you just show a simple double bond between 2 carbons, 1 carbon attached to a chlorine atom and the rest to hydrogens. For the 1-chloropropene geometric isomer, remember we must show different groups on each side of the double bond. So one side has a CH3 group and the other has a Cl atom. Next they say, explain why chloroethene and 1-chloropropene are members of a homologous series. This is because they both have the same general formula. They also have similar chemical properties because they contain the same functional group. The only difference between them is a CH2 group. Next they say, explain why 1-chloropropene exists as 2 geometric isomers, but chloroethene does not. The reason is that both molecules have a carbon-carbon double bond, meaning they both have restricted rotation. But in chloroethene, both carbons involved in the double bond are attached to 2 hydrogens each, so no different groups. Meanwhile, in 1-chloropropene, each carbon in the double bond is attached to 2 different groups, so it can form 2 different geometric isomers. In part B, chloroethene and 1-chloropropene are both monomers. Draw the structure of poly-1-chloropropene. To draw the polymer, just break open the double bond and extend the carbons to link together. Keep the Cl and CH3 groups on the side of each unit and add an N at the bottom to show many repeating units. Easy, just don't forget to remove the double bond. Next they say, the polymer of chloroethene, known as PVC, is used to make water pipes and gutters, which were previously made of metal. Suggest 2 advantages of using PVC instead of metal in water pipes and gutters, other than cost. Here you can say, PVC doesn't dissolve in hot or cold water, so it's super durable. It also doesn't corrode like metals do, so it lasts longer. Plus, it's lightweight, which makes it much easier to install. Question 22. The diagram shows the arrangement of electrons in the energy levels of a sodium atom. So here we see the arrangements of energy levels. Then they say, give the reason why the 2 electrons in the N equals 1 energy level are represented by arrows pointing in opposite directions. So electrons always occupy orbitals in pairs, but they can't both have the same spin. That's just a basic rule of quantum mechanics called the Pauli exclusion principle. One electron spins up and the other spins down, which is why the arrows are shown pointing in opposite directions. Then they say, explain whether or not all of the electrons in the N equals 2 energy level have the same energy. So the N equals 2 energy level isn't just one simple shelf, it's got 2 different subshells, the 2s and the 2p. The electrons in the 2s subshell actually sit at lower energy compared to those in the 2p subshell. So nope, not all electrons at n equals 2 have the same energy. Then they say, name the shape of the orbital occupied by the electron in the n equals 3 energy level. Remember that if it's an s orbital, the shape is always the same, spherical. Question 23. Samples of germanium consist of 5 isotopes, 4 of which are stable. The 5th isotope, germanium-76, is radioactive but with a very long half-life. This means that the isotopic composition is almost constant. The table shows data for 4 of the isotopes. Then they say, calculate the mass number of the 5th isotope of germanium. The relative atomic mass of germanium is 72.6. You must show your working. First, we're told that germanium has 5 isotopes. 4 are listed in the table and the 5th one is unknown. We're given their mass numbers and percent abundances and told that the relative atomic mass is 72.6. We start by calculating the missing percentage. 100 minus the sum of 20.5, 7.8, 36.5, and 7.8 equals 27.4%. So we then work out the missing value. Call it X. This is done by multiplying the isotopic abundances with their corresponding isotopic masses, including that of X. We then sum up all and divide by 100. This is equal to 72.6 as you see here. Rearrange to solve for X. 0.274x equals 72.6 minus 52.982 equals 19.618. X equals 71.598. We round this to 72. Next they say, give the main reason why the answer above should not be quoted to more than 2 significant figures. Simple, because a mass number is always a whole number. It's the total number of protons plus neutrons. So it shouldn't be in decimals or given to unnecessary significant figures. Next, the radioactive decay of germanium-76 forms stable atoms of selenium-76. Compare and contrast the atomic structure of an atom of germanium-76 with an atom of selenium-76. Both atoms have a mass number of 76, but look at their proton numbers. Germanium has 32 protons, selenium has 34 protons. So selenium-76 has 2 more protons than germanium-76. Since atoms are neutral, it also has 2 more electrons. Now flip it. Germanium-76 has 2 more neutrons than selenium-76 because 76 minus 32 equals 44 neutrons for germanium. 76 minus 34 equals 42 neutrons for selenium. Proton difference equals 2, electron difference equals 2, neutron difference equals 2. Question 24. A sample of a volatile liquid X was vaporized. At 473 Kelvin and 110,000 pascals, 3.50 grams of X occupies 1.79 cubic decimeters. Calculate the number of moles of X. We're using the ideal gas law here. Now always check your units. Pressure is in pascals, already given 110,000 pascals. Volume must be in cubic meters. So we convert 1.79 cubic decimeters to cubic meters. That's 1.79 divided by 1000. Temperature is 473 Kelvin. So plug into the equation, then divide all by 8.31 times 473. That gives you 0.05 moles. Next they say, deduce the relative molecular mass of X. Easy, just use the formula. M equals mass divided by moles. That's 3.50 divided by 0.05 equals 70. Next, compound X contains 85.7% carbon and 14.3% hydrogen by mass. Calculate the empirical formula. So you set up a table, assume 100 grams, so you get 85.7 grams carbon and 14.3 grams hydrogen. Divide by atomic masses for carbon. 85.7 divided by 12 equals 7.14 for hydrogen. 14.3 divided by 1 equals 14.3. Then divide both by the smallest value, 7.14. So the empirical formula is CH2. Next, deduce the molecular formula of X. We know the relative molecular mass of X is 70 and that of CH2 is 14. 70 divided by 14 equals 5. So the molecular formula is C5H10. Next, a few drops of a purple solution of acidified potassium manganate 7 were added to a sample of liquid X and shaken. The solution remained purple. State what can be deduced about the structure of X from this experiment. This is a test for carbon-carbon double bonds. Since the purple color did not disappear, it means X does not contain a carbon-carbon bond, so it's a saturated compound. Next, identify by name or formula two possible structural isomers of X using the answers above. Since X has a structure of carbon 5, hydrogen 10, and saturated, we are likely dealing with cycloalkanes. Answers are cyclopentane, methylcyclobutane. Question 25. Chlorine reacts with both alkanes and alkenes. In the first part, 3 steps in the mechanism for the reaction of chlorine with butane to form 1-chlorobutane are shown. Now, this is a classic example of a free radical substitution mechanism which occurs between halogens and alkanes. The process involves 3 main steps: initiation, propagation, and termination. Then they say, name the mechanism and type of this reaction. This is free radical substitution. We see radicals being formed and used to substitute a hydrogen atom in butane. Next, give the essential condition for step 1 to occur. For step 1, where chlorine splits into 2 radicals, we need ultraviolet light. The UV provides energy to break the chlorine-chlorine bond homolytically, producing 2 chlorine radicals. Then they say, name the type of step illustrated by step 3. Step 3 shows a propagation step. In this stage, the butyl radical reacts with another chlorine molecule to form the main organic product and regenerate another chlorine radical, continuing the chain reaction. In part 4, a different type of step other than the ones shown also occurs in the reaction. Describe this type of step, including 2 possible examples which might occur in this reaction. This is describing the termination step. In termination, 2 radicals combine to form a stable molecule, ending the chain reaction. There are a few possible ways this can happen. 2 chlorine radicals meet and form chlorine gas. Also, a butyl radical reacts with a chlorine radical to form the organic product. Both of these remove radicals from the reaction mixture and help bring the process to a stop. In the next part, chlorine is not a polar molecule but can react with alkenes through an electrophilic addition reaction. State what is meant by the term polar molecule and why chlorine is not polar. A polar molecule has polar bonds and an overall dipole moment due to differences in electronegativity. In chlorine gas, the 2 atoms are identical, so there is no difference in electronegativity, meaning no dipole is formed, it's nonpolar. Next, explain why chlorine reacts with alkenes even though it is not a polar molecule. In these electrophilic addition reactions, as chlorine approaches the carbon-carbon double bond, the high electron density of the pi bond repels the bonding electrons in the chlorine-chlorine molecule. This induces a dipole, creating a partial positive and a partial negative charge. The double bond then breaks and donates electrons to the partially positive chlorine, starting the electrophilic addition process. Question 26. Sulfur hexafluoride is used in the electric power industry as an insulating gas. It can be used in this way as it is very unreactive. Fluorine reacts with sulfur to form sulfur hexafluoride. Impurities of disulfur, decafluoride, and sulfur tetrafluoride also form and must be removed because they are too reactive. In the first part, give the name of the compound S2F10. This is a naming question using molecular prefixes. S2 means there are 2 sulfur atoms, so disulfur. F10 means decafluoride, so we write disulfur decafluoride. Next, molecules of S2F10 consist of 2 SF5 units linked by a sulfur-sulfur bond. Complete the dot and cross diagram of S2F10 showing the outer shell electrons. Use dots for the sulfur electrons and crosses for the fluorine electrons. To complete this diagram, we need to remember sulfur has 6 outer electrons, fluorine has 7 outer electrons. Each bond represents a shared pair of electrons. Lone pairs should be shown clearly on the fluorines, and all bonding pairs need to be included. A single sulfur-sulfur bond should be present, connecting the 2 SF5 groups as shown here. Next, draw a dot and cross diagram of SF4 showing all the outer shell electrons. Here, sulfur still has 6 valence electrons. It forms 4 bonds with fluorine atoms using 4 electrons. That leaves 1 lone pair on sulfur. Each fluorine has 3 lone pairs around it, as clearly shown here. Next, complete the table showing clearly the shapes of the other 2 molecules and the F-SF bond angles. Let's go row by row. SF6 shape is octahedral with all bond angles at 90 degrees. S2F10, each sulfur is still forming 6 bonds, 5 to fluorine and 1 to the other sulfur, so the shape around each sulfur is still octahedral. Bond angles around fluorines are 90 degrees. SF4, this molecule has 4 bonding pairs and 1 lone pair. The shape is seesaw and bond angles are approximately 90 degrees, 120 degrees and 180 degrees because lone pair-bond pair repulsions distort them. Next, justify the shape around the sulfur atom in both SF6 and SF4. This is a valence electron pair repulsion theory explanation. In SF6, sulfur has 6 bond pairs and no lone pairs. These bond pairs repel equally and arrange themselves in an octahedral shape to minimize repulsion. In SF4, sulfur has 4 bond pairs and 1 lone pair. The lone pair causes more repulsion than bonding pairs, which pushes the bonds slightly, creating a seesaw shape to reduce repulsion. Bond pair-lone pair repulsion is stronger than bond pair repulsion, which is why the geometry changes. Next, SF4 and S2F10 are reactive, but SF6 is unreactive. Suggest reasons for this by considering the shape and bonding in each molecule. Let's compare them. SF4 has a lone pair of electrons that can be easily donated or involved in reactions, making it reactive. S2F10 contains a sulfur-sulfur bond, which is longer and weaker than typical covalent bonds, making it easier to break and participate in reactions. SF6, on the other hand, has no lone pairs and contains strong short SF bonds that are very stable and not easily broken. This makes it very unreactive. So this brings us to the end of this video. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.